Hello everyone. This video is on the Knewton Alta assignment, section 3.4, part 1, called Combinations of Functions. So in this video, I'm going to be going over a preview version of this particular assignment. Please understand that the questions I see in this video may or may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same, so I'm hoping the questions are similar enough so that watching me do some helps you in some way when you work on the assignment yourself. Alright, so here's the assignment page. You got the title, got your mastery bar. You can see the objectives. Looks like there are 2 objectives. Under the current objective, there should be a question related to it. And then at the bottom of every question, there should be a feedback button where you can send feedback to Knewton if you need to. You will not have this instructor cheat button. It's for instructors only. But you will have the more instruction button. Click on this if you're ever struggling with a topic, and you'll be sent to a page with some reading or some videos or both, and then you'll be given questions related to that instruction. That'll hopefully help you, get through the assignment. All right. So this first question is on the objective. Create a new function by composition of functions. Alright, so I'm going to write out these 2 functions here. We have a function called f and another function called g, and we're asked to create what's called a composite function, g of f, or g composed with f. That's what this little circle symbol means. You're doing function composition. And function composition, you'll see, is basically just substituting one output into another function, substituting one function into another. Alright, so I got some paper here. So yeah, the first function we were given was called f, right? F of x is 6x minus 4. And g of x, another function called g of x is 2x squared plus 5. And we're asked to create what's called a composite function, and the order they're putting it in for us in this problem is g composed with f. So it's a totally new function. Alright, so yeah, this little circle symbol is composed with the composition operation. Now another way to express this, which again you may see in your text or other videos, is g of f of x with all these parentheses. G of f of x, like this. This is the same, they mean the same thing, both these notations. And it works exactly like it looks, or at least how I think it looks. You put f of x into g. So I guess if I want to explain it, step by step here, first step is, the value of x goes into f, and that yields f of x, whatever f of x is. And then this value f of x goes into g. Right, then f of x goes into the function g, giving me g composed with f of x, or g of f of x, like this. Alright, so as I was saying, x goes into f first. If x goes into f, the output is 6x minus 4. Right, so this happens first, right, the inside function. And I put it into g. Right, x goes into f, and I get 6x minus 4. right? And then f of x, right, this 6x minus 4, goes in as the input for the next function over, which is g. So remember how function notation works. You know, g of 6x minus 4, you just go through the rule for g, replace all the x's with this expression 6x minus 4. So instead of 2 times x squared, it's 2 times, 6x minus 4 squared. Right? Just x is replaced by f of x. Right? X is replaced by this 6x minus 4. And then you got plus 5. Alright, so this is what I was kind of saying earlier. Right? Function composition is basically just substituting one function into another. Right? Here it's f into g. Now be careful, they could switch the order on you. Just pay attention to what order. G composed with f means f goes into g. But if I switched it up and had f composed with g, that would mean that g goes into f. Right? And then of course we simplify. Right? They're asking us to, well, I don't know if you have to put in the simplified version, but I'm going to do it anyway. So remember, you raise things to powers first, exponents first. So this is 2 times, and then 6x minus 4, to the second power, that's 6x minus 4 times 6x minus 4, and then you got a FOIL. That would be 36x squared, right? 6x times 6x. And then you have 6x times negative 4 would be negative 24x, but then you'd have 2 of those, right? So you'd have minus 48x. And then you have negative 4 times negative 4, which is positive 16. Right, and then you still have the plus 5 afterwards. Now I multiply, right? You raise the powers first, then you multiply. Distribute the 2, and then I'll add the 5 after. All right, so we have 72x squared minus 96x, and then 2 times 16 is 32, then plus the 5 afterwards would be 37 plus 37. And here is the composite function, g composed with f. Right? And it's, like I said, just a lot of substitution. Right? Just a lot of substitution. One function into another. All right, so back here, that's what I'll enter. They have g composed with f at x equals, we simplified it to 72x squared minus 96x plus 37. Right. And submit. Now after you submit, right, it should tell you if you're right or wrong. And usually it might give you a second chance, right? But then, then afterwards you have an answer explanation. Please read through the answer explanations, especially if you're wrong, right? Try to figure out why you were wrong, and hopefully you can fix your mistakes in the future, or learn from your mistakes. Okay. All right, next question. All right, we're sticking to this objective, another composite function. So once again, I'm given a function called f and a function called g, and I'm asked to create a composite function. This time it's f composed with g, right? And the order does matter when you compose, right? If you've watched other videos of mine or read through the text, order does matter, right? F composed with g is not going to be the same all the time as g composed with f. Alright, so once again I'll write these out and we'll compose them in the order that they wish. So the function f, right, f of x is 4x plus 3. And another function g of x is 2x squared plus 5x. And we're asked to find, this composite function f composed with g, right, of x. Right? The input's always, usually x. Now once again, another way to write this would be f of g of x. Alright, so first x goes into g this time. Right? So this happens first. You kind of work from the inside out here. So we have f of And then what is g of x? G of x is this 2x squared plus 5x. Right, and then I take 2x squared plus 5x, I take g of x and put it into f. So I just go through the rule for f and replace all the inputs with 2x squared plus 5x. Replace all the x's with this quantity. So instead of 4 times x plus 3, it'll be 4 times this, right? 4 times 2x squared plus 5x. And then plus 3. Right? Just replacing the x in the function f with this input, with g of x. We distribute the 4, combine like terms, we get 8x squared plus 20x, and then you still got this plus 3 out here, and none of these go together. Alright, so there you go. That output is the result of composing f with g. And that's what I'll type. So f composed with g, this composite function is 8x squared plus 20x plus 3. That should be good. Wonderful. And again, please read through the answer explanations. Alright, next, now we're on the other objective, combining functions using algebraic operations, meaning adding, subtracting, multiplying, and dividing. And it's really as simple as it looks. If we're said, given the following functions, find and simplify, f minus g when the input is 4. Alright, so we have a function f, we have a function g, and we're creating this new function called f minus g. And it's as simple as it sounds. You just subtract f, do function f minus function g. That'll create this new function f minus g. So the operations are simple, I feel, here. There's no substitution really. It's just adding, subtracting, multiplying, dividing, depending on what operation shows up. Right. So we're given function f. Right, f of x is 1/2 times x squared minus 1/4 times x plus 4. There's f. And then this function g of x is 1/2 x minus 1. And we're creating a new function called f minus g of x. Right? And then we're going to plug in the number 4. Right? Again, it's as simple as it sounds. You just take whatever f of x is and then subtract whatever g of x is. So I could plug in 4 right now if I wanted. Find f of 4 and then g of 4 and subtract those. Or we can go through and do the whole thing, right? So f of x is this, 1/2 x squared minus 1/4 x plus 4. And then you're subtracting, be careful, you're subtracting, the entirety of g of x, which is 1/2 x minus 1. You're not just subtracting the 1/2 x, you're subtracting the whole thing. So I'm going to distribute the negative here. And when we combine like terms, we end up with 1/2 x squared. Now negative 1/4 x minus 1/2 x, remember that's 2/4. That'd be negative 3/4 x when combining like terms. And then 4 minus negative 1 would be 4 plus 1, that'd be plus 5. So here's the resulting function, this difference function, f minus g. And when x equals 4, we get the following. Right? F minus g of 4 is, just replacing x with 4 in this new function we just found. 1/2 of 4 squared minus 3/4 times 4, and then plus 5. 1/2 of 16 is 8. 3/4 times 4 is just, 3 minus 3, and then plus 5. So this is 5 plus 5. The output is 10. And this is what they want, the output of this new function when the input is 4. Now you could have also done this, like I stated this earlier. could have said, hey, f minus g of x, that's just f of x minus g of x. When I plug in x equals 4, it's just going to be f of 4 minus g of 4. And then, what is f of 4? Well, f of 4 would be half of 4 squared minus 1/4 times 4 plus 4. Half of 16 is 8. Minus 1 is 7 plus 4 is 11. And then we're subtracting g of 4, which would be half of 4 minus 1, which is 2 minus 1, which is 1. And 11 minus 1 is 10. So either way, you get 10. All right. So this shows you with these algebraic operations, you can do one of two things. You either find the new function in general, right, like we did here, and then plug in the input, plug in 4, or you plug in 4 to each one separately and then do the operation, right? Plug in 4 to f, plug in 4 to g, and then subtract them, do f minus g of 4. Right? Either way, you got 10. And that's what they wanted, right? That output. It's just 10. Great. And once again, please read through these answer explanations. So yeah, see what they're doing. There's plug into f, plug into g, and then subtract. They did the 11 minus 1 thing that I did second. Alright, we're still on this objective. Again, we have what's f minus g of x, right? So just in general, for any x. Alright, so once again, I'll write these out. And again, just pay attention to the operation. Is it addition? Is it subtraction? Is it multiplication? Is it division? Right? Or composition, right? You have that other objective with function composition. So we have f of x is negative 2 times x squared plus 3x and then minus 2. And then this other function g of x is x minus 4. And they want to find, they want you to find this new function called f minus g of x. And as I said earlier, this is simply f of x. So negative 2x squared plus 3x minus 2 minus g of x, right? Minus, and then g of x is the quantity x minus 4 here. And then be careful you're subtracting, right? So you gotta distribute if there are multiple terms. And combining like terms, we have negative 2x squared, and 3x minus x is positive 2x, and then negative 2 minus negative 4 would be plus 4. Negative 2 plus 4 should be positive 2. And here you go. This is the simplified version of f minus g. Now, if they did g minus f, it would be just the opposite of this. It would be positive 2x squared minus 2x minus 2, right? F minus g and g minus f are different, right? They're opposites. If you're adding, it doesn't matter what order. F plus g, g plus f, they'll give you the same thing. Same thing with multiplication. But subtraction and division, the order matters. All right, and so this is what I'll type in here, what I have in the circle. So we end up with negative 2x squared plus 2x plus 2. Great. All right, next. More on this. Same objective, different functions are given. And now we're asked to find and simplify, f divided by g. See, it's f over g, a fraction there. So it's f divided by g, and be careful with division, just like with subtraction, right? Order matters. F divided by g is the reciprocal of g divided by f, right? They're totally different. All right, so once again, I'll write these out and do it. So f of x is the function 2x squared plus 3x, and g of x is 2x plus 3. And we're asked to create this new function, f divided by g, of x, and just like it looks, it's f of x in the numerator divided by, and then g of x in the denominator. Now remember, denominators can't be 0, and I don't think they're having us write any restrictions here, but I'm going to point this out. Just remember that denominators can't be 0, so that means that, whatever 2x plus 3 is, this can't be 0, meaning that x cannot be negative 3 halves, right? So just keep that in mind. If you're talking about the domain of this function, it's all real numbers except negative 3 halves, right? Because that would make me divide by 0. All right, so as long as x is not negative 3 halves, we can continue. And then we got to simplify. They did ask us to simplify this fraction. Remember how to simplify a fraction. You factor the numerator, factor the denominator, and cancel any common factors. Well, the numerator factors to x times 2x plus 3, and the denominator is just 2x plus 3, times 1 if you want, because that's the greatest common factor of 2x and 3. And then hopefully you see that 2x plus 3 is a common factor. Again, as long as x is not negative 3 halves, you can cancel these. And all I'm left with is x over 1, so just x. That's it. This simplifies to just x. So whatever the input is, that's going to be the output, as long as x is not negative 3 halves. Because again, if you plug in negative 3 halves, this denominator would be 0 and you'd have an undefined expression. Now, you don't have to put the restriction, right? It doesn't say anything about putting the domain, so just find and simplify that fraction, which simplified to just x. Okay. Again, please read through. Now they should, that's annoying. They should mention that x can't be negative 3 halves here. Can't have denominators being 0. All right, just keep that in your head. All right, that should be in your mind. All right. Looks like we got one more question here involving the algebraic operation, and it's another subtraction. So again, you'll see plus, and you'll see just fg if it's times. If it's multiplication, it'll just be fg, and hopefully you remember how to multiply polynomials. But once again, it's just f minus g of x in general. So take f and then subtract g. Now g only has one term. So I'll have negative 2x squared plus 2x plus 3. That's f. Minus negative 4, which would be plus 4, making this plus 7 when you combine the like terms. So I got it right now. Negative 2x squared plus 2x. And then, again, plus 3 minus negative 4 would be plus 3 plus 4, which is plus 7. So f minus g end up being this function here. All right. So again, please know, like I said, the questions I'm seeing here, you might see different ones. Just know that you might see plus, you might see multiplication. Just understand that you're doing those operations if those ever show up. All right. And again, we have division. Okay, see, they're telling us that x can't be 1 here. So maybe I missed it. Maybe in the last one it said x couldn't be negative 3 halves. But the reason they're stating this is because, you can't divide by 0, as we'll see. Right? We'll see when I put these functions up, and we're finding the function f. Again, it's f divided by g. Just pay attention. It could be g divided by f, f times g, f plus g, f minus g, g minus f. Just pay attention and do whatever the operation states. All right, so we have f is 4x squared minus 4x. G is 4x minus 4. And we're asked to find this function, f divided by g of x. And again, it looks as it looks. It's as it looks. Numerator is f. The denominator is g. And again, they actually told us x can't be 1. Right? Because if x were 1, you'd be dividing by 0. 4 minus 4. Right? So as long as x is not 1, we can continue. Now if you factor that, now you can factor completely, but I'm just going to pull x out of the numerator. So it's kind of like the last problem I did with this division. Because if I pull, I know 4x is the greatest common factor, but if you pull just x out, you see how there's 4x minus 4 left. And then down here you got 4x minus 4, and those cancel. So I'm left with just x again. Alright, that's not always going to happen. Alright, it's not always going to be x with this f divided by g. You should know how to simplify fractions, though. Okay, it might end up being something else. Like I said at the top, the questions I'm seeing, you might see different ones. I'm sure you will. Alright, but this one happens to simplify to x again. So f of x, f divided by g of x equals x, again, as long as x is not 1. Great. All right, so that objective's done. Again, you might see addition and multiplication. Please be aware of that. All right, then the rest of it should be composition. All right, composition of functions. All right, so I'll do it again. Just write this on paper, f and g, and compose them in the order they want us to compose them. G composed with f here. All right, so f of x is 6x minus 1. G of x is 4x squared plus x. And they want us to find this composite function g composed with f. Alright, so once again, I like writing it the other way with all the parentheses. Another way to write this is g of f of x. Alright, so this is g of, and then, what is f of x? F of x is 6x minus 1. And then you're just plugging 6x minus 1 into g. So everywhere there's an x in g, I'm replacing it with the quantity 6x minus 1. So this is 4 times, instead of x squared, it is now the quantity 6x minus 1 squared. Plus, and then instead of x, it's the quantity 6x minus 1, and then we simplify this. All right. Okay, so 6x minus 1 squared would be 36x squared minus 12x plus 1. When you FOIL, do 6x minus 1 times 6x minus 1. Plus, and then there's no need for parentheses around these because there's nothing multiplied by, it's not being raised to any powers, so just 6x minus 1 at the end there. Then I would distribute the 4, and we'll combine like terms now. 4 times 36, that's 120, plus 24, that's 144 x squared. 4 times negative 12 is negative 48x, but then I got plus 6x over here, so negative 48x plus 6x would be negative 42x right after combining those like terms. And then 4 times 1 is 4, plus negative 1 is positive 3, and there we go. That's as simplified as that gets. And there's your composite function, g composed with f. Right, f is put into g. All right, and that's what I'll type. So we have 144 x squared minus 42x plus 3. Great. All right, and then there should be one final question here in this preview. Same thing, here's f, here's g, and once again they're asking for g composed with f, right? Just remember they might throw out f composed with g. Just pay attention to the order of the composition because it does matter. Okay, so here we go. F of x is 2x minus 2. G of x is 6x squared minus 3. And they want the composite function g composed with f, right? G of f of x. All right, so once again, I'll write it the way I like it. G of f of x, like this. And so this is g of And, what is f of x? F of x is this 2x minus 2. And so now I take, 2x minus 2 and plug that into g. Right? So everywhere there's an x in the rule for g, I replace it with this quantity 2x minus 2. So this is 6 times, and then instead of x squared, it is now the quantity 2x minus 2 squared. And then you still have the minus 3 after. Alright, now after squaring, 2x minus 2, you'd have 4x squared minus 8x plus 4. Right, if you FOIL. And then you have the minus 3 still, and then distributing the 6 and combining like terms, we'll have the following. 24x squared minus 48x, and then 6 times 4 is 24, but then you have the minus 3, right? So plus 21. And there's as simplified as that's getting, right? So this composite function made from these two, g composed of f, is 24x squared minus 48x plus 21, and that is what I shall type. 24x squared minus 48x plus 21. Okay, and submit, and that should be it. Alright, and please don't forget to, again, read your answer explanations, make sure things are making sense to you. And that should be it for this preview version of this assignment. Now, as I said at the top of the video and multiple times throughout the video, the questions I saw in this video may not be the same questions that you see when you work on the assignment yourself. But, all the objectives are the same. So the question should be similar enough to where, watching me do these few examples here hopefully help you in some way when you're doing the assignment yourself. Okay, and thank you very much for watching.